everybody, this is Mr. Munson, Unit 7, right triangles, 7.3 trigonometry functions. Okay, so we have three trig functions, and these three trig functions relate together in one equation, one angle and two sides. And the two sides are chosen by whatever angle we're looking at. Now we're going to go through this and hopefully you'll understand this. For some of you, this might be one of the first videos you've had to watch a couple of times, and that's okay. That's totally appropriate. This is brand new information. It's not the easiest piece. It's a lot of fun, if you ask me, and it's kind of interesting to see how this all plays out. But quite honestly, some of you will need to watch this video several times to grasp everything in there. That's your responsibility. Okay, let's go ahead and get started. Make sure you have those trig functions written down in your notes. We did all of our vocabulary in 7.1, and so today I'm just going to refer back to that page. We're looking at sine, cosine, tangent, and inverse trig functions. If for some reason you did not write those into your vocabulary sheet, here's a great opportunity to do so. Okay, all right, let's continue on. So one of the three of the I can statements is that you can write the trig functions sine, cosine, tangent. And so there's this word SOHCAHTOA, and it basically sounds like a Native American person. So there's this fictitious story out there of a chief or sometimes a Native American girl named SOHCAHTOA, and basically that word, just being able to say SOHCAHTOA, will help you spell out what these trig functions are, and it's just like one of those little tricks of the mind to help you understand it. So the first three letters, S-O-H, S is the sine part of it, and then the OH represents the opposite and hypotenuse part of it. And then the C comes along, and then we have cosine, and then the A and H represents adjacent and hypotenuse. And then the T comes along, and that stands for tangent, and that's equal to the opposite over adjacent. This is very important. When you write these trig functions, you need to make sure that you write a symbol after the trig function. So it's not just sine blank equals. It's got to be sine theta, sine B, sine A, whatever it is, whatever angle you're looking at, you can't leave it blank. Okay? So these trig functions, sine is like how something gets applied to a number. In another world, we have another function. It's called the square root function, and it doesn't sit very well by itself. It has to have something underneath it. It could be an x, it could be a number, right? So cosine, sine, and tangent are like square root symbols. It's a function that gets applied to a number. All right, hopefully we'll understand that in greater detail as we move on. So let's use this trig function to find some missing sides. So let's start with finding dg, okay? Now to find dg, I'm going to write a trig function, and so it depends on which angle we start off with looking to find a side. If we're looking to find this side here, and let's say we're going to use this angle 36.9, what we do is we see the 3 across from it, and we know that is, in reference to that angle, an opposite side. And of course, this is always going to be the hypotenuse because it's on the right side. So looking back at your trig functions, see if you can determine which trig function relates opposite to hypotenuse. Put me on pause just for a second. Go back and look at those if you don't know it right away. Well, I'm hoping that you got that the sine of theta is opposite over hypotenuse. That's the trig function that we're going to want to use. Okay? So, as I've always contended, you should write down the trig function. You should always write your equation, especially when you're learning it, without any information. Write it down as often as you can. You'll learn it. All right, so let's go ahead and take that information and plug it into the problem. All right, so I took the angle that we're working with and put it in the angle spot. I took the 3, which is the opposite side, and put it in the opposite side spot, and there's my equation. So I'm trying to find dg. So what I'm going to do is I always like to just turn this into a proportion, meaning there's a fraction now on the left, there's a fraction on the right, and just cross multiply. Okay, so the next thing I need you to make sure you understand is this right here is one big component. It stays together. It's just like if I wrote square root of 36.9, I can't just all of a sudden pull the number out of that, right? It's all tied together. And that's true with this thing, okay? This is this sine of 369 is all one piece. And you can't just take the sine and divide it out or whatever, or divide out by the 36.9. It is one unit. But what I am going to do is divide both sides by the sine of 36.9, and that will get the dg all by itself. So then I end up with 3 divided by the sine of 36.9. All right, it is definitely time for my calculator because I don't know how to divide 3 by sine of 36.9. I have no idea how that actually calculates out, but my calculator does. And so what I'm going to do is I'm going to go ahead and type that in my calculator. However, before I start, I need to make sure I'm in the correct mode. So on your calculator, go to mode and toggle down to radians, and then but toggle over to degrees, hit enter, and make sure you're in that degree mode. Whenever you pick up your calculator, make sure it's in that degree mode. Now, if you don't have a TI or something like this, a smartphone calculator has the sine, cosine, tangent calculator buttons built in. When you have your, if you take your phone and turn it horizontally so it's lengthwise and it's in calculator mode, you'll see it all of a sudden will change and you'll have this scientific mode, which has the sine, cosine, tangent. All right, so let's go ahead and type this in. All right, so I have 3 divided by the sine of 36.9. Let's hit enter, see what this turns out to be. Yeah, that's 4.9659. There was no rounding rule given or whatever. If it's all right with everybody else, I'm just going to call that, approximately 5. Okay, so I just found the hypotenuse of this triangle is 5. All right, very good. Now it's approximately 5, but we're going to go with it being 5. All right, so what I want to do now is just go and find that hypotenuse one more time. I already know that it's 5, but pretend I didn't. And instead of approaching it from this 36.9 angle, what I'm going to do is I'm going to approach it from this 53.1 angle. And I want to show you how it doesn't matter which angle you choose, you're going to end up with the same number. Okay, so now you're welcome to write this down with me, or you can just sit back and watch the math. All right, so I do some analyzing. I realize that this 3 here, in reference to that angle 53.1, is an adjacent angle. And of course, this is still the hypotenuse, and that's the piece I'm trying to find. So I look back at my trig functions, and I try to decide which one of the trig functions relate an adjacent to a hypotenuse side. So that's cosine of theta equals adjacent over hypotenuse. Always write it down blank. It helps you remember it. Okay? So then I take the pieces that are appropriate and put them in their appropriate spots. The 53.1 is an angle, so it goes in the angle spot. All right, so now I got to solve this. I'm going to go ahead and turn this into a ratio over here so I can cross multiply. And I'm going to go ahead and call this DG. Sorry. All right, cross multiply. Let's divide out by that. All right, so then we have DG equals cosine of 53.1. That definitely looks different than the equation I had before. Let's go ahead and check our calculator and see how that pans out. Okay, so I've entered it in, ready to see what it turns out. Sure enough, they're both exactly the same answer. It doesn't matter which angle I come from, whatever convenient for me. Okay, so they both turn out to be in DG is equal to 5. In this case, approximately equal 5. Now I could use a I could use my trig functions to find out what DO is, but I'm not going to do that. I'm going to go ahead and go on to another problem, let you try your hand at it on your own. Okay, so here you are. We're looking for x. So now what I want you to do is contemplate how you're going to go about doing this, okay? So one of the things, the kind of steps I do is I look at the angle. In this case, there's only one real angle I could use. I could go find the other acute angle that's at the top, but no need to do that. The 53 is given to me, so I'll just use that. So what you want to do is analyze how is the side x and the 15, what would be words that describe them in reference to the angle 53? Then go look at your trig functions and see which one uses those words. Write that trig function with no information in it. Fill in the information and go ahead and start solving for that unknown. Put me on pause. See if you can work this out on your own, okay? I'm hoping that you were successful and realized it was an opposite over hypotenuse kind of problem, which is sine. And now I'll just plug the information in and start solving for it. Well, that panned out pretty nice. Now it's time for my calculator. All right, so that turns out to be about 12, okay? Now don't take it as a standard that we always round, to the up and it's always to the closest whole length or whatever. But I'm just doing that for the sake of this program. Make sure that you're checking the directions to see how they want rounding of the sides. If it said to round to the 10th spot, then round to the 10th spot, wherever you need to go. Okay? So it would not matter. We would still find it to be 12 if we went and found this angle and used that angle to calculate what that missing side is. All right, let's move on to another one. All right, here's another one. Have at it. We're looking for how far, we're looking for CB. Okay, see if you can find that. Put me on pause, of course, and try to do it on your own. So the first thing I do is I look to see what words associate with the angle and the sides. 30 is definitely opposite to 35, and CB is the adjacent. Okay, so that would be tangent. So I fill in the information. I'm going to add that divided by 1 there to create a ratio equals a ratio so I can have a proportion. It's time for my calculator. And I got CB is approximately equal to 43. All right, let's move on. Now the inverse trig functions are the kind of the path that you would take and the thing that you would use to find an angle measure. As you can see in this triangle here, I have 3 sides. I really only need to have 2 sides, but I have 3 sides, and I'm looking for the angles D and G. Certainly O is 90. So what we would do is, let's say we were looking for D. Then we decide which side we're going to use. Just for simplicity, I'm going to get rid of this 4. Say we don't know that. Okay, so if I had that 3 and 5, what I would do is I'd look at how that 3 and that 5 associate with that angle D. And of course, that's an opposite and an opposite and a hypotenuse situation, which is sine. So we write down that function and then we put the pieces into it. All right. So the thing that we don't have is the angle, and that's apparent in the equation. So what we have to do is somehow get rid of that sine that's being applied to the angle so we can get it to be an angle equals some number. Okay? Let me just kind of diverge for a second and take you to someplace you know how to do stuff like this. In this world where you have x squared equals 5, you take the square root of both sides to cancel out that squaring. That's because square root and squaring are opposites of each other and they cancel each other out. How about this? If I have 5x equals 7, I divide by 5 because there's multiplication here, and the opposite of multiplication is division. To undo something, we do the opposite. Okay? So, while we were coming to understand this better this year, that squaring and square rooting are opposite of each other, and most of you get in the hang of when you see one, you want to undo the other, you just, do the other. So what we're going to do is we're going to have a function to go against the sine, go against the cosine, and go against the tangent, and you'll see how to do that right now. So here's the equation that we have, and again, we're trying to get that sine, or the sine moved, pulled away from that theta symbol, okay, to find out what that angle is. So what I'm going to do is watch very closely and follow what I do, okay? I'm going to put parentheses around this, and I'm going to apply this operation. This is called the sine inverse. So whenever you see that thing, you say sine inverse, okay? But whatever I do to the left side, I have to do to the right side. So I'm going to put parentheses around this and write sine of -1, or sine inverse, okay? Now, notice I didn't put it, whoops. Notice I didn't put it over here, put the sine piece over, sine with that little -1 on this side. I put parentheses on it, and I put it on that side, just so that it was exactly like the other side. What ends up happening is these two functions cancel out, and I have theta equals the sine inverse 3/5, okay? All right, so now let's pull open our calculator and see if there's some way of working this. So if you take a look at your sine key, S-I-N, Just above it in blue is that little sine inverse key. And to access that, you have to use the second key. So I'm going to type this in now. Just as a reminder, what we're trying to find is theta, this angle, okay? I'm taking the sine inverse of 3/5, which is the opposite over the hypotenuse relationship of those two sides. And when I hit equals, what I'm getting is not a side, but an angle. So that angle is equal to 36.9 degrees. And I beg your pardon because I've been using the letter theta here, and this really should have been D. I'm trying to find angle D, right? So if that caused you any confusion, I apologize. So we just found that the angle is 36.9 degrees, okay? Now, I don't know of another problem that we've dealt with this year where we had a way of calculating the angles. Trigonometry allows you to calculate the angles. Okay? So what I want you to do is I want you to do this next problem, and I want you to find the question mark angle, okay? Now I gave you three sides. You get to choose which side you want to use. When you have all three sides, you can choose any trig function. So see if you can set that up. I'm going to do it one way, and if you put me on pause, try to do it your way. My way might not be, my trig function that I chose might not be your trig function, but it's okay. The process is still the same. So go ahead and give it a shot. See if you can come up with the right answer. Put me on pause. So I'm going to label my pieces in the sense of what I think they're called, adjacent to hypotenuse. Now, if you didn't pick cosine, no worries. See if we come up with the same answer. If we did, that's a great experience for you to see it doesn't matter. Now, I need to break that bond from cosine and C. I'll break that bond by applying cosine inverse to both sides. It's time for our calculator. All right, turns out that it's 16.3 degrees. I gotta tell you, it's not too hard what we're doing here, but it looks pretty cool. And so, make sure you share this with your parents. Show them this work that you're dealing with. It's impressive looking. You got cosine. They probably don't even remember this or have any idea what you're dealing with. And so, show it up. All right, if you think you know what you're doing, go ahead and move on to the try it problems. I'm going to do one more problem right here. I'm just going to show the work real quick, just to give another example, okay? But if you feel like you got this, go ahead and go on to the try it problems and get those done. So let's say that we need to find A. Hey, look at that, one of our special triangles. There's your try it problems. Have fun.